All right, so our new unit is on algebraic expressions, okay, and then we're moving right into solving equations. That's one unit, okay? So today's lesson is on like terms and simplifying algebraic expressions. And we're going to learn to simplify algebraic expressions by collecting like terms, things that are alike. So if we look at the pictures, lines can go with lines, squares can go with squares, cubes can go with cubes. But you can't group cubes and squares because they're different, okay? It can't be combined or simplified. So like terms are algebraic terms with exactly the same variable and the same exponents, okay? So same variable with the same exponent. They can have different coefficients, the number up front, that tells you how many there are, okay? So when thinking of algebra tiles, like terms have the same shape. So this could be represented as 2x here, because there's two of them. This could be represented as 3x. If we have the white ones being negative, this could be represented as negative 5x, okay? And because they're all x's, we can group them. And actually, if we do group them together, if we add these together, does anyone know what we would come up with? Molly? It would be 0. Why? Okay, so this is 5x. And we're adding negative 5x, which gives us 0. Or you can think of 0 pairs here, so that a positive x and a negative x is a 0 pair, cross them off, another 0 pair, another 0 pair, and another 0 pair. They're all paired up, I'm left with 0. Okay? Good? All right, so then they've got examples here, so negative 6y cubed, 11y cubed, 4 times y times y times y. So if you multiply y by itself 3 times, it's y cubed. And y cubed, they're all like terms because they have the same variable part, okay? Just plain numbers, they're all like terms, okay? So look at each pair of terms and decide if they're like terms or unlike terms, okay? So we're just looking at them and saying like or unlike. We can use L for like and U for unlike. So 4x and 7y, like or unlike? Can we group them together, or are they separate? Unlike, good. They don't have the exact same variable part. Negative 7 and 13? Like. 4a cubed and negative 3a squared. Unlike. Okay, they've got the same variable, but not the same exponent. Okay? 7x and 7. Like? Unlike. Because this one doesn't have an x. They have to have the same variable part. The coefficients don't affect whether you can group them or not. 9x squared y and negative xy squared. Look carefully. Unlike? Why are they unlike? That is true. Why? Because on this one, the exponent 2 is on the x, and on this one, the exponent 2 is on the y instead. Okay, so even though they've got the same letters and the same exponents, they're on different things. So it means they're unlike. Negative m and positive 20m? Like. Okay, exactly the same variable part. This negative really means there's a negative 1 up front, negative 1m. Okay, so to simplify an algebraic expression, like terms can be grouped together and their coefficients added or subtracted. Okay, so if you look over here at the side here, 2x squared is represented by that part of the picture there. Okay? Negative 3x, so I'm underlining 2x squared in my first color. So I've got my first color out, 2x squared I'm underlining. My next color is I'm going to use red. It doesn't matter what color you use, but x squared and x aren't the same ending. So here's my negative 3x's. I'm going from left to right, then I see plus 4, so I've got to change colors because it's not an x squared ending or an x ending, so I'm going to change to green. And make sure you include the sign with your underlining, Josh. Make sure you include the sign in front with your underlining, okay? And that corresponds to those 4 there, okay? Now I'm back to an x squared again, a plus x squared. So I chose blue for x squared, so I'm going to underline this one in blue, and that corresponds to this x squared here shown at the side. And then I've got negative 3x. Well, I chose red for terms ending in x. I chose red for terms ending in x, so whatever color you chose for x, you're going to underline. And then I've got negative 2, a plain number, so I chose green for a plain number. And there's my negative 2. So looking at the picture here, just looking at the picture without doing algebra, if you add all these up, what do you expect that you will get? How many x squareds do you expect you will get? Just by looking at the pictures. 3. Okay, this is like the activity we did. How many x's and their negative x's? 6 negative x's, so negative 6 x's. 1, 2, 3, 4, 5, 6, and their negatives. And then how about ones? We've got 4 positive ones and 2 negative ones. Right, so we have a 0 pair here and a 0 pair here, and we're left with positive 2. So just by looking at the picture, that's what we would expect to get. If you're doing algebra, then we start regrouping, okay? So we put the 2x squared down, and I like to check it off that I've used it, okay? Then I look, where did I underline blue again, including the sign? It was plus x squared. Click that one off. I've done it. Okay. Now moving from left to right, the next thing I come to is negative 3x. So I write that down. So this is what we would do if we didn't have the picture. Okay, if we didn't have the picture. And then I'm going to look and see, do I have my second color anywhere else? Yes, I do over here. So negative 3x, this is called regrouping. And then again, from left to right, the next thing that comes is plus 4. And then the last one I have is minus 2. So this is called the regrouping step, where you put like things beside each other. Regrouping, where you put like things beside each other. Same here. Okay, so now they're all lined up. All we have to do is add or subtract integers, and we can use our calculator for that if we're not the greatest at doing them in our head, or we can do it in our head and then check on our calculator and make sure we're right. This means 2x squared plus 1x squared, right? So that gives me 3x squareds. I can combine them because they're both x squareds, okay? Then, including the sign, so negative 3x, I owe 3 x's, and then I owe 3 more x's. So on your calculator, you type in negative 3 minus 3, which gives you negative 6x. And then here, positive 4 minus 2 is positive 2. So if I didn't have the pictures, that is how I would algebraically do that. Okay? So use the colors, regroup, and then collect. All right. Well, we got another one that has a picture, and then the rest of them we won't have pictures for. All right, so I'm going to start off with blue again. Negative x squared, there it is in the picture. Negative 4x. got a different ending, so I choose a different color. There's my negative 4x's. Negative 2, there's my negative 2 1. Then I've got x squared ending again. I chose blue for that, so including the sign, I'm going to underline positive 2x squared, which are right here. I chose red for my x ending. Negative 4 of them right here. And then plus 4 ones. Okay, and again, looking at the picture, we can predict the answer without using algebra. Can anyone predict the answer by looking at the picture here? If we combine these, 1x squared, good. So those two cancel out and I'm left with 1. Negative 8x's, good. So they're all negative x's, and there's 8 of them, negative 8x. And then there's a 0 pair, there's a 0 pair, and I'm left with positive 2 ones. Okay? All right, so if we didn't have the picture, how would we do it algebraically? So whatever comes first, from left to right, click it off. Then look for the next like term, positive with the sign, positive 2x squared, click it off. Then what comes next, see if there's any other blues, there isn't, so what comes next from left to right, negative 4x, click it off. Another. Then what comes next from left to right, negative 2. And lastly, positive 4. So there's your regrouping step. Now you're going to group the like terms. So this is, you're thinking of this as negative 1x squared plus 2x squared. So you're talking squares here, yep.
3x squared?
Negative 1 plus 2.
So, negative 3 squared?
Negative, so you've got you owe me a square, and I give you 2, how many do you have? 1. Right? If you owe me 1, but I give you 2, then you're 1 ahead. Okay, so if in your calculator you would type negative 1 plus 2, and the ending stays the same because we're talking about squares here. Okay? Then I'm looking at negative 4x, so I owe 4 x's, then I owe 4 more x's, so I owe 8 x's. Negative 8x. If I was typing in my calculator, negative 4 subtract 4. Okay? Negative 4 subtract 4. Gives me negative 8. Here, this is one of the grade 9 errors. A lot of people put negative 6 here. What have they done wrong if they put negative 6 at the end? Alexa?
Because it's a positive 4.
Right, so they added the 2 and the 4 and then just called it negative. You can't do that unless there's brackets. So you're negative 2, you owe 2, you get 4, so you're good for 2. Okay? And you would type negative 2 plus 4 into your calculator. Okay, so I'm going to pause this and have you try the next 2 on your own. Catch up to you a bit here. Okay, so as I walked around, As I walked around, I noticed that everybody was able to identify which terms were like terms. Okay, so that was awesome. And then regrouping, well done. Okay, who thinks they've got the final answer for this one? Alexa?
7x squared.
Yeah.
5x plus 6. And positive 6.
Plus 6. Okay, so I saw a lot of people write it like that. What has to be in between 7x squared and 5x?
Oh, I said plus.
Oh, did you say plus?
Yeah.
Okay. But I just wanted to point out some people had no sign there. Okay, so You're saying that 7x squared plus is going to be and 5x's and 6 1's. Okay? So there, between each different type of term, there has to be either a positive sign or a negative sign. Okay? To indicate whether your terms are positive or negative. All right, for the next one, I'll start off with blue. X ending for me is blue, so I've got 3 that are plain X endings and 2 that are plain numbers. So then for my regrouping step, I'm going to start from left to right and put all my X endings together, including the sign. The sign moves with the term. And then from left to right, I see plus 11 and then minus 4. Okay, so there's my underlining, my regrouping, and who thinks they got the final answer for this? Charlie?
Is it 9x plus 7?
9x plus 7. Very close. What one change would you make? Braden? 10? So 5 plus 8 is 13, minus 3 is 10. Very good. Okay? All right, so on to the next one. So now instead of x squared, x's, and numbers, we've got a's, b's, and c's. It works the same way. So I'm going to pick a color to start with. I'll start with blue. So A is going to be my ending for blue. So I'm going to search through and see if there's any other A's. And then plus 5B, so red is going to be my color for B's. And green is going to be my color for C's, including the sign. So first step, underline. Second step is to regroup. And the sign moves with the term. So once you've regrouped and lined them up, that's when you just combine the like ones. And Alexa, what do you get when you combine the like ones?
9a plus 15b negative, like minus 3c.
Perfect.
Can I go to that?
Yes, you can. Okay, and then if we did the next one, if I start with blue, is there any other thing that ends with x cubed? No. So then I'm going to go to red. Is there anything else that has x squared ending? No. So then I'm going to go to green. Is there anything else that has an x ending? No. So I'm going to just use my pencil. So what does that mean? If I've got 4 different colors and 4 different terms. You can't simplify this one. You can't simplify it any more than it is. Okay. All right. So now we're going to apply it to perimeter. Can someone describe what perimeter is just in words? Like if I asked you to find the perimeter of something, what would you think you'd have to do? Add up the sides of the shape, yes. Okay, so it's the outer sides that you add together. So, and does anyone know what these little tick marks mean if you see them on a shape? Molly? They're all the same. So that means these are all 10x. So there's a couple ways you could do it. A lot of people like to do the perimeter ones vertically. I've noticed over my years teaching grade 9. Just maybe because you're used to doing perimeter that way. But if you add 10x plus 10x plus 10x plus 10x plus 10x, what do you get? 50x. And then because it's perimeter, just write P for perimeter equals 50x. Does that make sense? Okay. And I saw Abby do this, which is awesome. She did P equals 5 times 10x. And then we know how to multiply 5 and 10x, right? We multiply the coefficients. 5 times 10 is 50 times x. So you have the same answer. Okay, both are great ways to do it. There's often a question like this on EQAO, and the mistake people make is saying the perimeter is 5x plus 8. Can someone tell me if they say that that's the answer, what their mistake is? If they say the perimeter is 5x plus 8, which is a common mistake in grade 9, what are they doing wrong? They added these two sides together, but how many sides are there on a rectangle? 4. Do you see that? So this one, if it's a rectangle, that's going to be 3x plus 5, and that's going to be 2x plus 3. Okay? And again, I've seen lots of people do it vertically. So if you're going to do it vertically, make sure your x's line up and your numbers line up. In other words, your like terms are lining up with each other. And you're adding them all up to get the perimeter. So all 4 sides, not just the 2 that they label. That's not how they try to trick you. So then we're going to add up our number column. So that's positive 16 and 10x. So 10x plus 16 is our perimeter. 10x plus 16. So remember to add all 4 sides, and even if they just label 2, it's a rectangle. Okay, perimeter is adding up all of the outer edges. Okay, and our last example here. This one tells you the perimeter of the shape is 11x plus 6. So we know the perimeter has to be 11x plus 6. What is the length of the missing side? Does anyone have any ideas how we can do this one? Yep.
So take the perimeter.
Yep.
And then minus the 4x.
Yep.
And the 3x plus 4.
Okay, great. Okay, so that's exactly what I would do, Jacob. But I would probably, and depending on how complicated the shape is, add these 2 sides together first. So if I add these up, I'm going to get 7x plus 4. And then I'm going to do, so I've added these 2 sides, and now I'm going to do what Jacob said, which is to subtract 11x plus 6, which is the total perimeter, take away the part that I have, and now I'm going to subtract. Be careful, you're subtracting here. I'm going to highlight the subtract sign, so we're used to adding. So what is 6 take away 4? Positive 6 take away positive 4.
It's Northwood?
Yep.
Is Alexa Bassett there?
She just went to the bathroom.
Oh, okay. When she comes back, can you send her to the office for a sec?
Sure.
Thanks.
Okay, so positive 6, you're going to think to yourself, take away, minus. Positive 4 is positive 2, okay? And then 11x, take away 7x. 4x. So that side here must be 4x plus 2, which is D. Now I always like to check my answers, and I call this counting around. So 4x, and 4 more x's is 8 x's, and 3 more is 11x. So that works out. Positive 2 plus 4 is positive 6, so that works out. So I've counted around to check my answer and make sure it works out. Okay? Good.